Chapter 16, Chemical Equilibrium. Every system in chemical equilibrium under the influence of a change of any one of the factors of equilibrium undergoes a transformation that produces a change in the opposite direction of the factor in question. That's a quote from Henri Le Chatelier, who is the person that Le Chatelier's principle is named after. And he lived a long time ago. So we mentioned equilibrium on Monday when we were talking about reaction mechanisms. Now we're going to learn a lot more about it. So the speed of a reaction is determined by kinetics. And that's what we've spent the last 2.5 weeks talking about, is kinetics. How fast does the reaction go? The extent of a reaction is governed by thermodynamics. So the equilibrium constant, K, capital K, is a measurable quantity that quantifies how far a reaction goes. There are very few absolutes. And so in Chem 1A, we kind of assumed that all of one of the reactants is going to get used up. The limiting reactant is going to get all used up and make products, and that's how everything works. That's not really true. Most reactions do not go to completion. There's still some reactant left. And so the equilibrium constant helps us to know the extent of the reaction, how far it goes. So this equilibrium constant K, if that is large, it's going to favor the products. So if you have a large equilibrium constant, you're going to have a lot of products. If you have a small equilibrium constant, that means that you're going to mostly have reactants. We'll learn more about the reasons for the size of the equilibrium constant in Chapter 19, but that's for later. Okay, so let's look at the relationship between hemoglobin and oxygen in terms of equilibrium. As you probably know, red blood cells contain a protein called hemoglobin, and this is an illustration of that. It's very large protein, and so it's just abbreviated HB. Hemoglobin reacts with oxygen to form this complex. And when we write this equation, we have a double-headed arrow here, which indicates that the reaction can go in both directions. This is a chemical equilibrium. The concentrations of the reactants and the products are described by the equilibrium constant that we're going to learn about. And Le Chatelier's principle illustrates that equilibrium systems respond to changes in ways that maintain the equilibrium. So a chemical equilibrium is trying to maintain the status quo. It's like, I like things the way they are right now. You force a change on me, I'm going to do what I can to make things the way they were. Personally, I can kind of relate to this because I only like change if it's my idea, right? If somebody else imposes it on me, I'm going to resist. So hemoglobin will bind with oxygen, and it transports the oxygen from your lungs all over your body, right? So in your lungs, there's a lot of oxygen, relatively speaking. And so because there's a lot of this reactant, the reaction shifts to the right, and the hemoglobin will bond with the oxygen. As the blood with the hemoglobin goes through your muscles and organs and other tissues, the oxygen level drops because the tissues are waiting for the blood to bring it more oxygen. So if this oxygen level is lower, then the equilibrium shifts to the left, and the hemoglobin that is carrying oxygen gives it up, lets go of it. And so it really is a remarkable system where in the lungs where there's lots of oxygen, the hemoglobin will pick up the oxygen, and as it goes through places where there is less oxygen present, it lets go of it and provides oxygen to those tissues. So that's how it works in your blood. What about an unborn baby? Unborn babies have lungs, but they're not breathing air, right? They're being nourished through the mother, but there's no direct connection between their blood. So how does this work? Well, fetal hemoglobin, which is HbF, is slightly different than regular hemoglobin. It has a larger equilibrium constant, and so it's going to load the oxygen at lower concentrations. So we have the maternal blood and the fetal blood in very close proximity to each other. And so the fetal hemoglobin in the baby's blood will get oxygen from the mother's hemoglobin, even under those lower oxygen conditions. It will still load. Normal hemoglobin here would not pick up the oxygen that the regular hemoglobin is letting go, right? But because this is a special kind of hemoglobin, it will pick up that oxygen and can transport that to the baby. This is not something that I'm going to test you on, but it's just an illustration of the application of equilibrium. Does anybody have any questions?